I'm Scott Potter, and in this brief presentation, we're going to run very quickly through a demonstration on configuring an enterprise network using Cisco's own Packet Tracer software. For those of you unfamiliar with networking, Cisco is the leading developer of internet switches and routers. These are not like the ones in your home so much as in medium to large companies. So knowledge of Cisco technologies places you in very high demand. I routinely receive correspondences from recruiters all over the country, and I'm well on my way to attaining the highest professional engineering certification under Cisco. Packet Tracer is a simulator. It is one of many ways that networking students can practice creating and troubleshooting networks. There is no getting around the fact, however, that you must spend many hours in books and video tutorials as well, if you wish to pursue a career in networking. Now, most resources are actually free or very inexpensive. But if you wish to reach the most advanced level of training, you'll need to actually spend a few $100 on the actual equipment. Now, David Bombal is the instructor who actually created this Packet Tracer lab, and you would have to apply to his course to get all of his labs. Now, although David Bombal meticulously explains the binary to decimal conversions in this lab, I do not. I see that as something you should already know before doing this lab. There are many tutorials for practicing binary to decimal conversions. Also, you should be fairly comfortable using the command line interface, where you must shift frequently between modes. The configuration process is fairly simple, but there are a lot of devices in this lab. This presentation includes only the essential clips and screenshots to show just how quick and easy this lab is once you actually know what you're doing. Now, if you're new to all of this, you'll find this presentation full of important information and a great leap forward in your understanding of networking. Now, the first thing we're going to do, we see a list here of 9 basic steps. It's actually fewer than that, and we'll run through it here real quick. We'll configure the network as follows. You have been allocated a subnet of 192.168.1.0/24. Now, you need to break that network into 4 subnets. Now, subnet 1 is for site 1, subnet 2 is for the link between router 1 and the internet router, subnet 3 is for site 2, subnet 4 for the link between router 2 and the internet router. Now, you're going to configure the router per the instructions in the diagram, and we're going to cover that first. You've been given a network of 192.168.1.0/24. Now, you need to break that into 4 networks, which means that we must borrow 2 bits from the host portion of the address, since the square of 2 is 4. Therefore, each address will be a /26, not a 24. If you don't fully understand all that, don't worry, I'm about to break it down a little bit better for you. Now, the process for creating subnets is actually very simple. In fact, the iOS is going to do that for us once we log in and assign the IP addresses to the interfaces with the appropriate subnet masks. So we're going to start the process with these 3 devices, each of which has 2 interfaces that need to be configured. The process is basically the same for all 6 interfaces. Then we're going to configure these layer 3 switches, which is really simple for this lab. There's really not much to it. Finally, we will configure these servers. Now, each server has 3 dialog boxes in need of information. We'll go through that when we get to that stage. When we are done, we should be able to ping all devices to make sure that they communicate with each other and that all the PCs on both networks can resolve the names for the Cisco and Facebook websites. Now, the remote servers for DNS, Cisco, and Facebook are in the simulation to confirm our settings are correct. These are not real Facebook or Cisco websites. This is all within the simulation. All right, we now need to follow steps 2 through 5 by assigning the last available IP addresses in each subnet to the networking interfaces and servers. The first available IP addresses at the 2 sites will be dynamically assigned by the DHCP server according to the IP pools that we will create later. Best practice is to first plan and add the labels to the topology, then actually log into each device and configure per the labels. Okay, first a word about best practices. These first steps are pretty simple, so long as you are already comfortable with the command line interface. The steps will be repetitive. From global configuration mode, you will go into the appropriate interface and use commands very similar to how R1 is configured here. Where IP assignment of networking devices is concerned, the devices most proximal to the lowest subnet in the hierarchy will get the first available IP addresses. These are never dynamically assigned. Only end-user devices are dynamically assigned. Notice that when you use the appropriate subnet mask, the Cisco iOS automatically creates the subnet ID and broadcast address. As I've already mentioned, I will not explain the process of subnetting in detail. There are, in fact, other tutorials that do this, and you should already be well beyond understanding the remedial arithmetic. So I'm simply going to show you how it works in this lab. Now, IPv4 addresses use the quad octet format, where each X in this representation represents an 8-bit value for a total of 32 bits. From left to right, some of the bits represent a network, and the remaining bits represent a range of assignable addresses to hardware interfaces. Identifying network bits from host bits is done using a subnet mask. In this case, we start with 24 network bits with a remainder of 8 host bits, hence the 24. When we actually go to assigning these addresses, the last available ones go to the networking devices, while the first assignable addresses will be dynamically assigned by the DHCP server. Okay, here's how it works for this lab. We're simply going to skip the conversion and simply run with the idea that if we have to break a larger network into 4 smaller networks, then we need to borrow 2 bits from the host side, since 2 squared is 4. That means that all 256 unique values for the last octet will be divided by 4, which equals 64. Now, each new subnet will have subnet IDs 0, 64, 128, and 192. Each subnet will also have its own broadcast ID, which is the last number before the next subnet. Those numbers are 63, 127, 191, and 255. Now, these reserved addresses basically serve as bookends, between which there are 62 assignable addresses in each subnet. All right, let's look at the range of addresses that we can assign on each of our subnets. In the first subnet, and we're just looking at the last octet, the numbers are 1 to 62. In the next subnet, the numbers are going to be 65 to 126. In the next subnet, it's going to be 129 to 190. In the last subnet, it's going to be 193 to 254. So here we are, starting with router 1. We have to go to the G000 interface. Now, that's a hardware interface, and that identifies, those numbers identify the actual location of that device if we were inside of a data center. If you go into a data center, you're going to have a certain device, it's on a certain rack, and it has a certain port on it. That information is going to identify it, and we're going to give that physical interface a logical IP address. Now, this G000 interface on router 1 is also going to be the gateway for subnet 1. So we're going to have to remember that later on. And that one has the IP address 192.168.1.62. While we are still in interface mode, we're going to go over to the S010 interface, and we're going to give that an IP address of 192.168.1.65. Now, you will notice that in all of these cases, we're going to give it a subnet mask of 255.255.255.192. That is because we have borrowed 2 bits from the host portion in the last octet, and that gives us a subnet mask of 192. The subnet ID for the last subnet is the same as the subnet mask. Here, we are going to see the same thing for the internet router, and then we're going to do it again for router 2. All right, now that we are finished configuring the routers, we're going to go straight into configuring the switches with the second to last IP address in the subnet. So we're going to start with the first switch. And one of the things we're going to notice right off the bat is that we need to change the name of it so that we don't get them confused. So we're going to go into global configuration mode, and we're going to change the name to SW1, and then go into the second switch and do the same thing and call it SW2. Then we're simply going to give them a new IP address, give the interface a new IP address, and then we're going to type IP default gateway. Now we're going to get that address to the router. And the reason we have to do that, or all of these devices, we have to do that because all network traffic that is destined for another network needs to know what device to go to, what address to go to in order to get out onto the internet or to get to another network. Now that we're done with the switches, we're going to go to the DHCP servers, and we're going to give those the third to last IP address. That's where we're going to create our IP pools that we're going to assign to the individual computers and devices that need to get onto the networks. All right, so we have three dialog boxes in need of information. The config and fast Ethernet, we got to put our information in there. Then we got to go over to the settings, and that we have to put we're going to statically assign the IP address. Remember, only end user devices get the first assignable addresses. We use the last available addresses in the subnet to go to networking devices and servers. So that we're going to do that. We're going to put in the DNS server. Now the DNS server goes out onto the internet in this case, and it's going to look for the server. It's basically the Google DNS server. Now DNS just means domain name service. It gives us the ability to translate names like Cisco.com into an IP address. We go into a browser and we enter the name Cisco.com, and it resolves that into an IP address. Then we're going to go into the Services tab, and we're going to click on the Service DHCP, where we're going to put our default gateway, which again goes to our router. And again, we have to put in the DNS server. And we need our start IP address for the range. Now, this will usually open up in Packet Tracer anyways. It opens up with the subnet ID. We need to go up one address. So we need, instead of 0, we need to put a 1 there. The subnet mask, again, is going to be 255.255.255.192. And we need to make sure that we have turned the service on. Look at that setting at the very top there. Now, once we have done this, we then click Save. When we save that information and we're good to go, we're going to go to the next server and do exactly the same thing. Here we see on the other server that we have an IP address of 188, and we are going to use basically the same information, same subnet mask. We're still going to have, we're going to use a gateway of 190, which is the interface for our router 2. And again, the DNS server is going to be 8.8.8.8. And we're also going to make sure that we've turned the service on, that we have a certain range of addresses. And one of the things you want to notice is the maximum number of users. Now, you can probably put in there, it should default to whatever the maximum number of addresses is in the subnet, but you can't assign all of those because some of those have already been statically assigned to servers and switches and various other devices. So what you need to do in this case, since you have a total of 62 assignable addresses, it would probably be best to use a number like 50, a nice round figure that gives you at least 12 addresses reserved for static addresses. Then, of course, you're going to go and save it. Now, this is not a real-world situation. It would probably be a little bit more complicated than this, and you would probably need to go into a Windows Server application or it depends on who you're working for. But Packet Tracer gives us this option to set this stuff up so that at least we understand logically what we're doing. All right, I hope you enjoyed this little demonstration on subnetting. I know it seems like a lot of information coming at you fast, But that is the great thing about videos and being able to view them at your own pace and as often as needed. I plan on making dozens more of these videos in the not-so-distant future or as time permits, so thank you for viewing, and I hope to see you next time.